Okay, good to. I was trying to change to speaker mode. Okay, here we go.
Perfect. So just let me move this and let's start. Well, hi everyone. My name is Jocho Ojeda. I work for the company Sari and I'm a Microsoft MVP and DevExpress MVP. And today what we're going to do is we're going to have an introduction to semantic kernel. So to understand what is semantic kernel, we will need to kind of go through some of the AI concept mostly because the code is like really lean. It's not so much code in general to show. So you can achieve a lot with little, just a few lines of code. So let's see. Let me move Zoom. This Zoom bar is huge. It takes like a huge chunk of this screen. Okay, so we're doing this as part of the Microsoft AI season of AI 2024. So if you want to give some feedback on this meetup, you can scan that QR code. And you can check this later on YouTube when we share it. Okay, so talking about AIs, you have always this joke, and this meme is part of the presentation itself. It was already there. So it's like, can AI write the talk for you? And well, I guess this part of this text was generated and maybe also part of the code. So some of it was written by name because I wanted to create an original example. So, but we'll talk about that a little bit later. So generative AI, everyone is talking about this lately, right? So generative AI is the way to basically generate an output based on like a smaller set of instructions. So basically you make a request and then you predict the next set of words that you're going to have. And then you present it like in a way that is like an answer. So it looks like you're interacting with the model, even though you're only appending the next prediction of an answer. So to understand all the concepts, first we have the large language model, which basically is a set of predicting paths that, given one input, the possibility of having an output is you have some probabilities that that text is correct, but it's all of that is probabilities. So then you have the models like GPTs, for example, that they have the complete interaction of, okay, you get an input, then you convert it into vectors, then you check those vectors into the model, and then you generate an output. So, and in the end, it looks like this, their, like this output. So you have the original model, then the prompts or text to process it, and then the output. So this is how it looks like. You have the natural language input, then this input is pre-processed, and then the tokens are extracted from it. And a token is not exactly a word, it's almost like the concept of a word. Is, the same idea of tokens happen on the zip compression. Basically, you check all the possible words that you can have, then you make a dictionary out of that, and you replace, imagining a text like this, you will replace all of these tokens for a number. So basically, it can be seen as a type of compression of meaning. You reduce the words exactly to their meaning, numerical meaning. So then you pass these tokens to the model, and then the probabilities are being calculated on the distribution. Then this is decoded, and then you have the natural language output. So a lot of things are going here. So having a large language model is not only it's not the only part on AI, to interact with AI. So that's why we have things like semantic kernel that help us to do all this process in just a few lines of code. So you'll see how easy it can be. So this is kind of how the input output looks like. You get n tokens for input, and then you get one token output. So you can continue passing the history and the history of your conversation, and you will always get the next part. So that's how it works. Okay, so here how is the idea how a token is generated. As you can see, in some cases it's a word, and in some cases it's part of a word. So imagine that each of the tokens they have some weight specifically. That's why they exist like this, because it's more probable to have like the word stop, for example, in one single word than having anthropomorphism in one single word. So see this split one in three, because it's more likely that you happen to get one of the segments than to get the whole word. That's where the tokens come from. And you can take a look to the tokenizer in this URL if you want to check how any of the text that you have can get tokenized. But again, this principle is it's really close to the idea of how seed compression works. So, and this is an example of how the prediction is working. So as you can see, you have here the input. We need the most likely word to continue after this is stop. And this is the most continuous stop and drop. And as you can see, it's building up until you have the full answer. So it's like kind of an iteration all the time. So this is, as you can see, this is translated to the token values. And then you get the numerical values of the natural language. And with that, you basically query the large language model. And well, since what we saw before is basically like the underneath functioning, like how the interaction with AI models looks like. Now we need to talk about prompt engineering, which is basically how we will instruct the AI model, how we embody it basically. So you can have different styles of prompts. For example, giving instructions like translate this from this language to this other language. You can have completion, which is you send a single request and then you get a single output. You don't continue with the history, even though with basically you can emulate the memory interaction. We'll see that in code. And then like a simple question, this in code, they look both the same. You get a single completion. So then like these are some tips that you can use to give instructions to the model, because you will understand a lot on how we speak when you try to give instructions to a model. You learn that we assume a lot of things in general, that we don't give enough context to other humans. So basically the idea here is that you will, by kind of making the prompt, you will also be learning how to express yourself in that sense, because the more well-defined that you have your request and the behavior, the more accurate the answers will be. So the tips are avoid assumptions, of course, try to be explicit, break down the problems that you want to solve. For example, translate this into that, and provide details, and if you can, provide examples. And okay, so not all prompts are the same. You have user prompts, which is this, like what we saw before, like you have either a single chat completion or you continue like in a history, emulating like a conversation with someone, so like a chat. So, but you have another type of prompts, which are the system prompts, which is the initial prompt that you send to the large language model. And that set the tone of the behavior and the next answer. So here's where you can tell the examples. Like, for example, you can say something like, uh, give a list of facts and then tell only answer questions where the answer is in the list in this list of facts. Or if you don't know, if it's not here, say I don't know. So you can limit the behavior of the of the large language model by using the system prompt. And actually, system prompts, you can send them each of the time with the request, so you can change the behavior basically on each request. It's not something that is steady. It's basically stateless, so you can change it all the time. So this is how a user prompt looks like. What can you tell me about John Doe? And this is what the assistant will say. That doesn't have any information about that it's only an AI. And it will try the best to give a unique answer. So talking in text. Basically, since we have these like two type of interactions, the chat completion and the chat itself, so where you interact like if you're having a conversation, uh, given those tools, you can have this set of outputs. For example, content generation. You can tell something like, write an article about database normalization rules, the normal forms, and it will write that. So basically, you can generate text with this. And also it can generate format text. For example, tell me, like, write the same article in Markdown language. That can be another type of content. It's not necessarily pure text, right? Then summarization, given like a chat history, you can tell me the meaning of this, of explaining like 100 words, they resume the whole conversation. So that's really cool if you don't want to read through a really long chat history. That can be good for meetings, for example. Code generation is kind of the same as content generation. I will put code in a category of content. So it's the same as generating Markdown. There is no difference between that. The other one this is kind of the most famous actually so far, is the semantic search, which um, these are vector operations in databases, which you tokenize a request, that you do a query in a vector database to see what is most likely to be near these vectors. Then you return the set of answers, and then from those set of possible answers, the model will choose like how to create an answer out of that. And the simple case, the most common one that everyone have seen, the chat interface, where you're chatting with an AI model. All of this can be done using semantic kernel with a mostly almost a set type of structure that, like the structure is really 99% alike. Only a few details change. So prompt engineering for text generation. This is how it will look like. You set the persona of the AI and the style, and you give it a chat history. The chat history can be empty at the beginning, but the history will act at some type of memory. So, for example, you can save the history from one conversation, start a new interaction with the semantic kernel for chat completions. And then if you pass that chat, it will think the model will think that it just happened, that it was generated by it. Then you do like meta grounding, which is provide all the possible context that you can inject from outside. Basically, that's how you add information to the system prompt. So You can tell, okay, these are the possible answers, answer this like that, and you give more context. For example, you can, if it's a game, you're talking about a game, you can give the set of rules. And then the AI can evaluate the game based on the set of rules that you have given to it. So is what happens behind the scenes, basically. And then also you can implement this like in a even more steps. You can just get the answer that was generated by the AI, or you can also create another AI, another kernel, and with another chat completion, and you can say like, can you check that this is safe, that doesn't have any racist comments, that doesn't give like wrong information, so on and so forth. So you can usually what you have to do in this type of um, AI interactions is like, okay, um, you never show the direct output of the chat completions to the user. You post process, you check with another agent, like, okay, is this the answer for this question? That you will avoid like awkward moments mostly. Then talking into numbers. Okay, so basically the idea here is that everything that we use as natural language get translated basically into embeddings. So generating embeddings is a big part of the AI interaction. And the beautiful thing is that with something like semantic kernel, we don't have to worry about that. That will kind of happen for you. So it's kind of a high level abstractions. And also um, it groups all and orchestrate all the possible services that you need, because imagine that you're using Azure OpenAI and then you want to interact with a local model that you have with LMS Studio, and one use one type of tokenizer and another other type of tokenizer. So if you have to do it line by line, you have to have two different version. I mean, really different um, code bases, and then you will not be able to share stuff between them. But with semantic kernel, I think like for me the best way to describe it is like an agnostic ORM to do AI interactions, or the same that WCF will be for networking, which is a set of abstractions. You interact with abstractions, and then you have the underneath implementation. So uh, uh, in this case, you can share a lot of code and create different use cases using different backend AIs with a single set of code. So that's really, really beautiful. There's no way to describe it. So here you have an example of what I was telling you. So you have the meta prompt. Then you have the documents that you're providing to the to the AI. So that's kind of the context. All of these can be hidden messages in the conversation. And then you pass the prompt for this comes from the user. And then what will happen is that you will get a response like this. So you see there is like a two steps before doing interaction. Like you have to set kind of the personality of the model and then give it some sort of information. So the prompt can process that and then generate the output. And when you have to do like retrieval augmented generation, which is RAG, the most common case, it's the same. You have the user question, then you have to query your data, and that you usually do it with vectors, so you need the embeddings. And then from that, you add, you pass your data, and then you query the model. This is something like these are the possible answers, and make your answer out of this input, and then you send the result. So it's a lot of kind of pre and post processing, because first you need to query your database, and it has to be a vector database for this to be more accurate in general. So let's see. It's time of the demonstration. So I will demonstrate the MVP that Microsoft provides in the set of examples, which cover one scenario, and then I created like two of them myself. So you can see the how to work with these use cases. So you can download the source code from that URL, and basically you can get also all the steps from the README in the source controller. So let's play with code. So first, see, this is the example that we're going to use. I wrote this afternoon, see 9 hours ago. The first step that we need to do is add the nugget packages. So for example, here you can see that I'm adding all the semantic kernel packages and the OpenAI connectors. These OpenAI connectors will work for Azure OpenAI or for OpenAI itself. So with this, you have like most of the ground cover in general. After that, you need to create, and this is optional. If you're only going to use Azure OpenAI or OpenAI itself, you don't need this handler. But if you want to use semantic kernel with an OpenAI compatible API, you'll have to have this handler. I think in the new version of semantic kernel, they have an overload for this, but right now you have to create a handler and then get the request that you were going to send to OpenAI or to Azure OpenAI and send it to whatever backend you are using. And we're going to do an example of that. So then you have to create an instance of the HTTP client. So if you want to connect to a local model, you need to redirect the request. So in this case, we're going to redirect the request to localhost 1234 because I'm going to run local models for the first example. And then you have to initiate the kernel. So before we go deeper into this part, I want to show you like LM Studio. LM Studio is like a free tool where you can download different type of models. You can search for whatever model you want here, and depending on your GPU, my GPU is kind of old, so I can only load like really small models. Then here is my set of models that I have. Usually the one that I like the most is this one, Cypher. This is fast, but sometimes it goes crazy. And the one with most stable behavior for me is this schema. So what you have to do in these cases is like right now I'm running V3 from Microsoft. So let me eject this, stop the server, and let's load schema. So this is feeding everything into the GPU. So this here is done, the server is running. And it's working on this URL basically. And okay, so we're ready to go. So the first case is we're going to use the test project here. So as I show you, I have the handler here. So this handler is going to redirect the request, and the request is being redirected to here. That is actually the URL, as you can see here, of the LM Studio. So we have the local handler. Then this is how you should create a kernel if you want to point it to Azure OpenAI. In this case, it's slightly different. But what I'm going to do, the first case is like, I'm going to run this with OpenAI itself. So I'm going to get a key and a model, and this is my system prompt. And then I will generate a single response. So this is not a conversation. If you see, there is no chat history here. I'm just invoking the prompt. So it's like, This is the input, append the output. So let's see. So the model is going to tell us something about El Salvador, but in this case, I'm using GPT-4o. So let's see what I deleted. We can see it here. So let's see what we got for answer. So El Salvador is the smallest and most densely populated country in Central America. It's bordered by Honduras, Guatemala, and the Pacific Ocean. The capital is San Salvador. So it's mostly Spanish speaking, of course, and so on and so on and so on. So yeah, this answer is actually correct. So this was a single answer, and this used GPT-4. So let's change this a little bit. So we use the local model. So to do that is, okay, here we have an OpenAI chat completion. So in this case, is asking for the model name, a key, and a handler. So what I'm going to do is I'm going to take this client. It has the handler that redirects the the call. So let's see. I think we have too many parameters. It should be like this. Or hold on, let me get it from the other. Which is here. Oh, it's not that parameter. It's a property. It's also not a parameter of the constructor. So it was good. Let's see. Let's go back here. And it was good like this. Okay, so in this case, we're going to use the client. So the model is going to be ignored. It's not going to use GPT-4 because we don't have that model. So the model is what we're going to use is the API will just answer, and it will answer from the model that we have loaded. And then the key will be ignored too. So here I will just delete it and put it like this. And then the client will redirect the request. So let's see what the Gemma model, Gemma can tell us. So let's go. And of course, an error. Then see. Okay, so let's stop this. I think I already break. So let's see. Let me get it again from the other example. The demo effect. I practiced this. OpenAI completion. Okay, this should be the line. Okay, so let's see. Again, these parameters are going to be ignored because we're going to use the local server. And let's see here. Okay, there you go. See, now it's generating the tokens and everything. So this is the output. So now it's calculating inference. So here there's still no answer. It's still waiting. And that's why I put a big timeout, because it can take time, especially if you're using local models. So let's see, check the response. And value, and then content. So sure. So here, see it, and this model was kind of fast and it's really accurate. This is the one that I like the most because it generates really good text. So El Salvador is a Central American country known for its stunning landscapes and vibrant culture located in the Pacific coast. Hold on, let me close this. So, with numerous temples, pyramids, and ruins scattered through the country. So, yeah, it's kind of a really happy answer, but it's also accurate. So, see, in this case, we're using a local model and not a remote model. Usually, GPT-4 is kind of really, really cheap, so it's not worthy to kind of go to the hassle to use local models, but sometimes it's nice to see how it's working. Like you can see here how the answer is getting calculated, and you can change some of the stuff of the server. If you have a nice GPU or a decent GPU, it's fine. And this model, for example, is really easy on the computer. So that was our first interaction with semantic kernel. So as you can see, it was super simple. We just needed to build the kernel and add the OpenAI chat completion. And then it was a single instruction, invoke prompt. So the next example, we're going to do it like in a unit test project because we need to do some interaction there. So, okay, so the idea here is we have a console project and we're going to use the console as a chat console. So regarding the references is the same that you can see in the README file. You can just go step by step and copy the little pieces of code. So this is going to be an interactive chat because the one that I showed you before it was a single prompt. You send one question, you get an answer. So this one is going to be a little bit different. So in this one, well, the first part is you decide if you're going to use a local model using the handler or you're going to use a remote model. In this case, we're going to use actually GPT-4. Then the first part is basically the same as the other example. You add chat completions and you build like a kernel. After that, you get the required service, you get the service for the chat completion service in general, and then you create the history object. In the history object, you set the first message, which is the system message, like how you tell the persona, like how you should behave. And then you pass the prompt execution settings, which is the maximum amount of token that you can use for an answer, the temperature, which will decide the level of randomness of the completion, and top P, which is the diverse answer that you can get for the same question, how different they can look if you iterate several times. So then this is like something that I was trying to do this afternoon, try to make this look more beautiful. So I was adding some colors to the console. And then you have the chat loop. You will see something like this in a lot of semantic kernel example. So uh, we we'll run this, and just to explain you here, the flow is in the loop, we are reading the input from the user. Then we append this input, we get a history message, and we add to the collection of messages that we have as history. And then to the chat service, we always pass the full history. We pass the settings. So this that the max tokens and how creative it should be. And then we pass the local kernel. It will use this kernel to generate the output. So the tokenization and all those things will happen behind the scenes for us. You don't have to do that code, like piece by piece. And then we will get a list of messages that is the answer. Depending on your settings, you might get the answer in a single message, or you can get also multiple messages. And then basically we'll write the answer to the console, and then we look back and we continue asking things. So this, when we set the system, is like you're on a system that will give me a list of 5 facts about a country. And basically it's a historian. So let's change this to, okay. So let's run this one. Okay, so hi. Let's be educated and say hello to the model first. So let's see, I want, tell me happy facts about El Salvador. Let's see what is considered happy facts. Okay. Beautiful beaches, and that's totally true. Sorry for my Caribbean friends, especially the ones from Dominican, but the Salvadorian beaches have like some beauty. I mean, I will not change the beach there. I love it. I used to live really close by, like 20 kilometers. Okay, rich cultural heritage, yes, of course. Like we come from Spanish people, and then like some native tribes, really interesting ones. Excellent coffee, also true, and happy happy fact. And natural beauty, of course, we have like beautiful nature, and it's really easy to access because El Salvador is small, so you can drive, have breakfast in the beach, have lunch in the city center, and then have dinner in the volcano. And of course, people like me, warm and friendly. So yeah, interesting facts. So this is the chat. So then I can tell like, now tell me happy facts about Chile, especially what happens on September. September is the independence month of Chile. So let's see what the AI can tell us about that. Of course, you have Fiestas Patrias, which is the celebration of the independence from Spain. Danza Cueca, which is something that is kind of the representation of the dance of the rooster and the hen and the chicken. I don't know exactly how to translate this. Then delicious food, you have empanadas chilenas. You have anticuchos, true also. So fondas arramadas, those are the little parties where people celebrate independence. And of course, the patriotic spirit. So yeah, Chilean flags everywhere. So yeah, now see, it's like an interaction. We are like talking, and it's kind of iterating on what we said before. So the loop is adding to um, the chat history. Actually, in most applications, then you will have to serialize this, save it in the database, and then read it back at one moment if you want to come back to this type of conversation. It's not like the AI, like the model will save something. You keep the conversation. That's the whole context. So I will ask one more question just to so you can see the history object. Now tell me fun facts about Spain. And the demo is going good. Last time I ran out of API credits in the middle of the demonstration. So let's put it here. And now we can check this object and see we have so far 9 iterations. The first one was the first prompt that where I set the tone, like the system prompt, then this first hi, and then the conversation back and forth. So all the time you're processing all the history. And okay, that's good. And the last example is the official example that came with this talk. It's a little bit different setup, but it shows a different infrastructure mostly because it ends up doing kind of the same. So in here we have a web application, which is basically an API, and then a client application, which is a console application that will send basically a prompt like from the user. So this one is a little bit different in the sense that we are creating a context. So, and the context is basically, it comes from this file, facts about El Salvador. I was really patriotic today. Everything was about El Salvador. So it's the largest country in Central America, known as the land of volcanoes, official currency is US dollars, famous for high quality coffee, of course. We did have a civil war, and surfing is a big deal there. And I like that we're getting famous for things like this. Okay, so too much about El Salvador already, I guess. So we get the facts for El Salvador. The original example was using a piece of source code like C# source code to ask something about that. But I thought like let's make it more fun. And so the idea here is that you have this, and this is basically an API. So this is the endpoint. Then you get the embeddings for the text of the question. So you generate the embeddings. Then you set a persona. And then in this case, you evaluate a prompt. It looks a little bit different, but I mean, the code looks different, but the flow is exactly the same. The only difference is that in this case, we're passing the embeddings, and that's basically the only difference. So here the persona that we are going to use is you're a historian and your expertise is in history of El Salvador. But you can only answer from the list of facts that we're passing. So the list of facts is what you read in the file that I show you, this one. And let's see, please answer, and then you concatenate the question. So it's like, please answer this question, and then we concatenate the question. So after this, you process as is a single completion all the time. And then you stream back the answer to the client. So let's see if they ask about any other country, answer that you have not visited that country yet. Let's see, this is a last minute modification. And okay, so in the client is kind of really easy. You basically do an HTTP request, and then you see it's like 4 lines, and then you look back the enumerable, and then you basically write the answer little by little. So in this case, I'm going to set both of the projects as a startup, so it can start both at the same time. And the second thing that I'm going to do is just to show you, I changed this a little bit. This usually use APP settings, but I don't like to use it. I use like environment variable. So Here is the line to get the environment variable, which is called like this. I get the key and then I pass it. That's the difference. The original code was using the settings. So let's start. And let's start with the negative prompt first. So tell me something about the country of Chile. So if you remember, the original prompt is it should only answer facts about El Salvador. And those facts should only come from the provided context. And it should answer something like, I have not visited that country yet. Let's see. And it's good. See, I'm sorry, but I have not visited Chile yet. My expertise is in history of El Salvador. That's cool. It's behaving good. And then the next question is, of course, tell me something about El Salvador. Let's make this bigger because I don't know if you can read it. Tell me something about El Salvador. Okay, basically it uses all the information on the file. It basically answered me back the fact, but I should have tell me just one fact. And all of these are true. The currency is US dollars. We had a civil war. The famous beach is El Tunco, which is that for surfing. We have indigenous heritage. Our main dish is pupusas, which is one of the most tasty things that you will ever try. It's like something like a taco, but it's like with the filling inside. And then about our weather. So the thing is that all these answers are answers from the file, but they are not exactly the same text. It didn't basically just output this set of strings. It told me in a conversational way about these facts, but it didn't listen one by one, which is what I want because I want a human-like behavior. And basically, that's it. As you can see, like in conclusion, it's really easy to start interacting with AI models. Either you're using a local service, or if you're using um, something like Azure OpenAI or OpenAI itself. So we encourage you to take a look to the official semantic kernel examples and to take a look to the sample code. This is publicly available, the one that I did for this meetup. And I think that will be everything from my side. Javier, are you there? Okay, I guess Javier is not here, so it's time for me to tell like the last words of the meeting. So, or I guess it's coming back. No. Okay, everyone. So thanks for coming. Thanks um, for joining this topic, even though it's a different one, not exactly like something related to SAF, but we have shown many other SAF examples before, and we will continue doing more integration and showing more ways to integrate XAF with AI. And well, like if you have any doubt, you have any experience that you want to share, please contact us back in the Facebook group. So I guess see you everyone in 1 month. So see you guys. Let's stop sharing and we are gone.